Hi everyone, this is Professor Nancy Mahan. Here's a question from the factoring lesson. The question is, the length of the longer leg of a right triangle is 19 inches more than 5 times the length of the shorter leg. The length of the hypotenuse is 20 inches more than 5 times the length of the shorter leg. Find the side lengths of the triangle. So you want to find the lengths of the shorter leg, longer leg, and the hypotenuse. So blah, 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 blah. The main idea is that when we first read a word problem, we want to ask ourselves what type of a word problem this is. And this is what I would say is a geometry word problem. In a geometry word problem, you want to draw a picture of the shape that you're working with. So the shape that they're talking about here is a right triangle. So again, a right triangle has a 90-degree right angle, and a right triangle always has two legs. So I'll call this leg 1 and I'll call this leg 2. So the legs are what creates the 90-degree angle, and then the longest side of the triangle, which is opposite of the right angle, is always called the hypotenuse. So that's what we need to know about a right triangle. So a right triangle is made up of two legs and a hypotenuse. So normally we call these legs, it doesn't matter which leg is which, but normally we call them A, B, and then the hypotenuse we call C. So the legs, again, it doesn't matter which one is A and B, and the hypotenuse is C. So based on Pythagorean theorem by a man named Pythagoras, his theorem says that there is a relationship among the sides of this right triangle. So in the Pythagorean theorem, it says that for a right triangle, the formula or the relationship between all three sides is a squared plus b squared is equal to c squared. So that's the main formula you need to know. So looking at this problem here, let's go ahead and draw the picture, right triangle. And now let's go ahead and fill out what we know is given. So here, the length of the longer leg, so I'll call this the longer leg, and I'll call this the shorter leg, right? So again, it doesn't matter which one, as long as one is on the leg side and the other is on the other leg side. The length of the longer leg is 19 inches more than 5 times the length of the shorter leg. So first, we don't know what the length of the shorter leg is, so I'll just call the shorter leg x. So the length of the longer leg is means equal. So the length of the longer leg is 19 inches more than. So more than means you're going to add 19. So more 19 inches more than, but you're adding 19 to what? So there's some blank here. So 19 inches more than, well, it's more than what? 5 times the length of the shorter leg. So 5 times the length of the shorter leg means 5 times x. So 5 times x, so I have 5x plus 19. So the longer leg here is 5x plus 19, again, because it's 19 inches more than, so add 5 times the length of the shorter leg, and the length of the shorter leg is x. Right, and now let's see what else is given. The length of the hypotenuse, here it is, there's the hypotenuse, is 20 inches more than, so I'm going to add 20, because you're going to, more than means adding, 20 inches more than what? So there's some blank here. More than 5 times the length of the shorter leg. So again, it's 5 times the length of the shorter leg, and the length of the shorter leg is x. All right, so now we're going to use the Pythagorean theorem to solve for x. So since we know this is a right triangle, we can create an equation using the Pythagorean theorem. So leg squared plus leg squared equals c hypotenuse squared. So here, 5x plus 19 squared plus x squared is equal to 5x plus 20 squared. So a squared plus b squared equals c squared. And again, you could flip these around, so it doesn't matter which one went first. It doesn't matter which leg is which, right? Which leg went first. So you can switch that around if you like. So again, I got this from a squared plus b squared equals c squared here. Here's the leg squared plus a leg squared equals the hypotenuse squared. All right, so let me just move this up here. So now that I have an equation, now I'm going to go ahead and expand it. So when I expand it, I get 5x plus 19 times 5x plus 19, and then plus x squared right there, equals to 5x plus 20 times 5x plus 20. All right, so it looks kind of scary because there's so much going on, but you guys have the tools to do this because you guys know how to use your algebra skills to do this, right? So here we're going to FOIL it. So when I FOIL it, I get 25x squared plus, so 5x times 19 plus 5x times 19. If I do that twice, I end up getting 190x. Plus 19 times 19 is 361, and I have plus x squared. Right? So on the left side here, I can combine the x squares. I end up getting 26x squared plus 190x plus 361. That's the left side. Now the right side, 5x times 5x is 25x squared. 5x plus 20, if you want to write it out, is 100x. 20 plus 5x is another 100x. Plus 20 times 20 is 400. So here, I could combine the like terms, which are these two. I get 25x squared plus 200x plus 400. All right, so notice with this problem right here that the highest exponent is x squared. So therefore, I know that this is a quadratic. Whoops. So since it's a quadratic, I'm going to use the steps from my factoring worksheet that I showed you before of how do you solve a quadratic. So here's that worksheet. So steps for solving a quadratic is first rearrange so that the equation is equal to 0, right? So you want this to be equal to 0. So I see 26x squared and 25x squared. I'm going to subtract this over. So I get minus 25x squared. I'm going to subtract the 200x. I'm going to subtract the 400. And when I do that, this all becomes 0 on the right side. And then on the left side, I get x squared minus 10x minus 39. Sorry, I'm trying to do it in my head right now. So hey, what do you know? This looks really nice and simple compared to what I first started off with. Once I have it set equal to 0, what do I do next? Step 2 is to the big F word, factor. Factor using the steps for factoring. So here, is there a GCF? So here I'm going to write factor. Is there a GCF? No. How many terms are there? 3 terms. So what am I going to do? I'm going to use, if there's no GCF, 3 terms, I'm going to do the Xbox method. So here, the Xbox method, I'm going to say, what 2 terms give me x squared? X and x. What 2 terms give me 39? Well, I'm not sure. Let me think. 39, is this divisible by 2? No. Is it divisible by 3? Possibly. Check this out. This is where a calculator is handy. 39 divided by 3. Yes, it is divisible by 3. And 39 divided by 3 gives me 13. So therefore, 13 and 3 here give me 39. I know one of these will give me, so one of these is going to give me a negative because I need a negative 39. But right now I don't know which one's going to be a negative. So I'll just leave it positive for now, but one of them will be negative. So when I do the x, I get 3x and 13x. Can I add or subtract this to give me a negative 10x? The answer is yes. If I put a negative 13x, I end up getting negative 10x, which is what I want. So these are my winner chicken dinner numbers, but I need a negative on negative 13. And like I said, one of them had to be negative to give me a negative 39, right? So winner chicken dinner, these are my numbers that win the factoring game. So when I factor this, I end up getting x minus 13 times x plus 3 is equal to 0. What do I do after that? Well, step 3, apply the ZPP, yeah, you know me. In other words, zero product property. So the zero product property says that if A times B is equal to 0, then the factors must also equal to 0 as well. Then A must equal to 0 or B is equal to 0. In other words, set each factor equal to 0 and then solve for your variable. So here, this is a factor and this is a factor. Set each factor equal to 0 and solve for x. So here, if I add 13 to both sides, I get x is equal to 13. If I subtract 3 on both sides, I get x is equal to -3. So in terms of solving this problem from this equation, the answer is x equals 13 and x equals to -3. But now, since it's a word problem, we always need to look at the answer in the context of the word problem. So if I know that x is 13, x -3, that means that the short length of the triangle is 13 or -3. Well, does it make sense for the length of a triangle or the length of a side of a triangle to be -3? No, it does not, because a length of anything cannot be a negative number. So therefore, even though this is the correct answer in the context of the quadratic equation, it is not the correct answer in the context of a word problem. So you can't have a negative length, but you can have a positive length. So therefore, the short length of this triangle is 13. So if this is 13, then what is the long length of the length of the longer leg? So what I do is I just plug it in. 5 times 13 plus 19. So I'm going to take out my calculator here because 5 times 13 plus 19 is equal to 84 inches. And then the length of the hypotenuse is going to be 5 times 13 plus 20. So 5 times 13 plus 20. So that's going to be 85. So here, so let's just double check, right? Let's just double check our answer. The length of the longer leg is 19 inches more than 5 times the length of the shorter leg. Is 84 19 inches more than 5 times the length of the shorter leg? Well, 5 times the length of the shorter leg, 5 times 13, 5 times the length of the short leg is 65, and then 19 inches more than that, plus 19, gives me 84. Ta-da! And then the length of the hypotenuse is 20 inches more than 5 times the length of the shorter leg. So 5 times the length of the shorter leg, so 5 times the shorter leg is 13. So the hypotenuse is 20 inches more than that, so I'm going to add 20 to that, and I end up getting 85. Ta-da! 85. So here, as you can see, this is the answer. You can also double check by saying, is a squared plus b squared equals c squared? So I'm just kind of going above and beyond right now to show you that this should meet the a squared plus b squared equals c squared. So if the shorter leg is 13, the other leg is 84, and the hypotenuse is 85, does it make sense? Does 13 squared plus 84 squared equal to 85 squared? So let's check our work. So 13 squared plus 84 squared, syntax error, plus 84 squared is equal to 7225. What is the answer on the right side? 85 squared is 7225, but damn, that works. Let me know if you guys have any questions.